capturing an eruption from the Black Diamond Pool at Yellowstone National Park on Saturday.
Released by the USGS, it shows the eruption blasting out of a thermal pool, sending water several feet into the air.
The government shutdown has now entered week 2, and both sides of the political aisle continue to blame each other with no end in sight.
Right beneath the geysers and steaming vents of Yellowstone, a discovery so unsettling has forced authorities to do the unthinkable: shut the park down entirely. The dramatic move came after scientists detected something deeply ominous, a presence in the subterranean realms that defied expectations and raised fears of something far worse than a simple geological anomaly. The normally vibrant park where tourists wander among hot springs and wildlife corridors now stands silent, its gates barred, its trails empty, because what lingers beneath has overwhelmed all sense of safety. Before we start, smash the like and subscribe buttons for more updates. The discovery began with a new set of subterranean scans. Using advanced seismic imaging and underground sensing arrays, teams observed a zone some 3 to 4 kilometers below the caldera, where neither rock nor simple magma seemed to dominate. Instead, the readings indicated enormous cavities filled with pressurized supercritical fluids, gases, and molten rock, interacting in ways nobody expected. The boundary between these zones and the standard crust was sharply defined, hinting at a dynamic system on the brink of transformation. That lid, which once quietly restrained the volcanic forces, appears less stable than believed. Prior to this, Yellowstone was already known to harbor a magma reservoir beneath the surface, with occasional gas emissions and hydrothermal activity indicating movement. But those fluctuations had always been gradual, gentle breaths in a sleeping beast. Now, the beast is stirring. The seismic waves bouncing through the crust no longer followed the predictable patterns. They slowed, distorted, and shifted in ways consistent with a growing void or destabilizing structure. Sensors recorded faint tremors that spread outward from the deep chamber, seeming to pulse in rhythmic but escalating fashion. Scientists believe fractured rock and expanding volatile gases might be reshaping underground pathways, potentially rupturing that crucial barrier between magma and brittle crust. When the Park Service first heard of the anomalies, they watched warily. But the escalation was too fast. The cavity's internal pressures threatened to burst local strata, and any sudden shift could trigger a cascade, new fractures, geyser blowouts, or even a mini eruption. The risk to visitors was immediate and real. Without hesitation, officials ordered a full evacuation zone, sealed trails, and closed access roads, typically open landscapes. Boardwalks to thermal features and backcountry routes all fell under the ban. There was no precedent for shutting Yellowstone entirely for geological reasons, but this event surpassed precedent. To understand why the threat is so serious, one must imagine the subterranean mechanics at play. The cap over the magma reservoir, previously understood as a stable lid of semi-solid, partially crystalline rock, is now seen as under strain. Gas pockets, supercritical water, and molten zones are exerting pressure from below. The cap's integrity depends on subtle balances, tiny fissures, and slow leak-off of gases. If that balance tips, the cap could fail violently. Once it does, hot magma and fluids could surge upward, traveling through fractures and feeding new pathways that reach the surface. Geothermal explosions, steam-driven blasts, or rapid expansion of gases could unfold in seconds. In that context, the shutdown isn't just precaution, it's necessity. Surface features like thermal pools or fumaroles that appear stable might be fed by conduits passing directly over zones under tension. If those conduits shift, a tourist could be standing above a rupture zone. Paths once safe might collapse into subsidence pits or be pierced by sudden eruptions of steam and rock. The quiet landscape, in truth, hides a volatile engine in crisis. The implications stretch further than Yellowstone. This event could rewrite our understanding of supervolcano dynamics. If a massive cavity is forming, it suggests that magma chambers can reconfigure faster and more violently than models predict. The interplay between fluids, gas, and molten rock might be far more active, with thresholds near critical points previously thought stable. Scientists will need to recalibrate how they monitor volcanic systems, not just in Yellowstone but around the world. Countries with supervolcanoes or major volcanic fields will now watch this unfolding drama closely. If Yellowstone's cap can weaken so suddenly, other systems may hold hidden instabilities waiting for a trigger. Earthquakes, tectonic shifts, or even human activity like geothermal drilling. The shutdown sends a stark message. Our knowledge remains fragile, and nature retains capacities for surprise. For the region around Yellowstone, shutting the park carries weighty ripple effects. Economically, it brings shock. Towns that rely on tourism, lodgings, restaurants, guiding services, suddenly lose their lifeblood. But beyond economics lies existential tension. Inhabitants must now reckon with how close they live to a massive planetary engine. The closure forces families in gateway towns to face warnings many dismissed as remote possibility. For scientists, the pressure is immense. Every moment the park remains closed is time spent without data collection in open conditions. But the alternative, risking lives, means no compromise. Inside the research community, teams are scrambling. Seismologists deploy additional sensors across Yellowstone's network, trying to capture shifts in real time. Geophysicists rerun simulations with new parameters reflecting a growing cavity and possible rupture thresholds. Hydrothermal specialists reassess how water and gas move through fissures, possibly fueling explosive pathways. Volcanologists re-examine data from prior Yellowstone cycles, looking for overlooked anomalies that may foreshadow this event. Cross-disciplinary coordination accelerates. The alarms, however, keep growing. Local authorities coordinate with park management, emergency services, and federal agencies to establish zones of exclusion. Helicopters monitor fracture lines and ground changes. Remote drones survey thermal areas for anomalous heat signatures. Any sudden increase in soil gas emissions prompts a lockdown of nearby zones. The shutdown isn't passive, it's constantly adaptive. If sensors flag a new fissure or temperature spike, closures expand. Roads once permitted may suddenly become off-limits. Media attention intensifies. Rumors swirl of Yellowstone's volcano awakening, and speculations mount of doom scenarios. Officials struggle to balance public communication. They must alert and warn without inciting mass panic. Messages emphasize caution, not catastrophe, yet the gravity cannot be hidden. Communities bordering the park hold town meetings. Emergency officials prepare evacuation plans for low-lying areas, and schools begin geological briefings to students on what might happen. The psychological impact is profound. Tourists who once dreamed of photographing Old Faithful now grapple with the specter of eruption. Scientists once confident in Yellowstone's dormancy confront the prospect they underestimated the system's volatility. Within parks personnel, morale is strained. Many feel helpless watching their lands slumber under threat, unable to welcome guests or guide them through wonders now off-limits. Meanwhile, in laboratories across the nation, deep Earth modelers work feverishly. They test new equations for fluid rock interaction under extreme pressure, revise magma flow models, and explore how gas-laden chambers dega over time. If this cavity continues to grow, might it evolve into a new magma chamber? Could it connect to peripheral magma pockets, triggering a cascade of melt intrusion? And critically, what triggers failure? Is there a telltale signal, a tremor, a shift in gas ratios, a sudden tilting of the crust that foretells collapse? Those questions accelerate into global urgency. Adjacent U.S. geological agencies monitor other volcanic systems, drawing lessons from Yellowstone's upheaval. They reassess monitoring protocols, consider deploying denser sensor networks, and reevaluate their worst-case scenarios. Budget requests that once seemed overcautious now gain sudden gravitas. The Yellowstone shutdown becomes a fulcrum point in national volcanic preparedness. On the human scale, scientists working inside the park, in labs and remote field stations, feel the weight of every measurement. Each anomaly in their charts could presage disaster. Nights become tense watches of seismic spikes. Days, endless scrutiny of rate changes in gas emissions. The complexity of the system, rock hardness, fissure networks, fluid pathways, temperature gradients, adds to uncertainty. Each new data point may shift interpretations in unexpected directions. Some argue the shutdown should prompt permanent changes in how we treat national parks atop geothermal systems. Perhaps continuous subterranean surveillance becomes mandatory, with automated sensor arrays and real-time alerts. Perhaps rapid response protocols must exist to evacuate zones above risky anomalies before danger emerges. Yellowstone's closure might become the benchmark for future precaution in volcanically active parks worldwide. Yet the greatest implication is existential. Nature's teeth can still catch a sleeper unawares. A national treasure now lies sealed not by human decree but by geological unrest. Yellowstone stands as both marvel and warning. Beneath its surface, beauty roils the power of Earth's engine. and until its secrets are parsed, until pressures recede or the cap reasserts itself, Yellowstone will remain locked, not by policy, but by the urgent decree of deep Earth itself. Beyond the closed gates and silent campgrounds of Yellowstone, the Earth continues its slow, relentless conversation, a dialogue of pressure, heat, and transformation. What began as an alarming discovery beneath the park has now evolved into a monumental challenge for scientists and policymakers alike. The very forces shaping the North American continent have turned volatile, and beneath that wilderness of forests and rivers lies a geological theater operating on scales far beyond human comprehension. What makes this situation particularly haunting is not only the presence of instability, but its unpredictability. Every hour, the instruments buried deep in the soil send new readings, strange vibrations, subtle distortions in gravity, surges of underground heat that defy familiar patterns. Something beneath Yellowstone is stirring, and its behavior is rewriting what humanity thought it knew about the planet's most formidable natural engines. As teams rotate through field stations, the challenge has shifted from detection to interpretation. The underground cavity, first thought to be a bubble of pressurized fluids, now appears to extend in irregular branching corridors, natural conduits threading through semi-molten rock like veins of living fire. These tunnels conduct heat unevenly, creating localized stress points where the surrounding crust expands and contracts. That means the ground above may be far less stable than surface appearances suggest. Sensors along the Norris Geyser Basin recorded micro-movements, tiny flexes of the crust, imperceptible to the human eye but massive in geological terms. Each motion hints at redistribution of pressure, the subsurface equivalent of lungs inhaling before a roar. The implications of those findings reach beyond Yellowstone's boundaries. The park rests atop one of the most complex mantle plumes on Earth, a column of molten material that rises from hundreds of miles below. If this plume's upper regions are fluctuating or producing new melt zones, it could signify changes in the planet's deep Earth circulation. Some geophysicists argue that what's happening isn't just a local event. It may be part of a broader reorganization of magma pathways under the western United States. This idea unsettles those who once viewed Yellowstone as an isolated anomaly. The closure of the park, once seen as a regional emergency, now represents a case study in continental-scale geological behavior. Inside high-security labs, mineralogists examine fresh rock samples taken from the periphery of the park before its shutdown. These rocks tell stories of ancient eruptions, 3 cataclysmic events that reshaped the continent and blanketed skies with ash tens of thousands of years ago. In their crystal lattices, scientists trace signatures of pressure and temperature that mirror present readings from the deep cavity. The parallels are unnerving. It's as if the park's foundations are revisiting a pattern last expressed during those prehistoric convulsions. The geological clock might not tick regularly, but its echoes repeat. Yet, despite the gravity of the discovery, there's a strange fascination among researchers. Yellowstone has always stood as both wonder and warning, a living archive of the planet's creative destruction. To witness its transformation, even from afar, is to glimpse the Earth's primal mechanics at work. Remote sensing satellites now orbit with enhanced focus on the region, capturing minute shifts in surface elevation. Each new dataset becomes a piece of a vast puzzle, a mosaic revealing how the hidden world below breathes. Some images show doming of the terrain, the land swelling like an enormous tide beneath forests and meadows. Others reveal heat anomalies spreading through the groundwater systems, implying that deeper conduits are feeding into surface layers with renewed intensity. The government's decision to cordon off the area has allowed scientists to establish an unprecedented observational perimeter. Without human interference, they can deploy equipment directly over danger zones, drones, magnetometers, and thermal imagers that operate continuously. What they're finding is both mesmerizing and terrifying. Methane and carbon dioxide emissions have surged in localized plumes, suggesting chemical reactions between magma and carbonate rocks at depth. Those reactions produce explosive gases and generate seismic tremors when trapped. Moreover, magnetic field readings fluctuate dramatically, implying that molten material is migrating. The landscape may look peaceful, but beneath that deceptive calm lies a pulsing molten heart in flux. As these revelations accumulate, discussions among experts turn philosophical. The Yellowstone discovery forces a re-evaluation of humankind's relationship with the planet. For centuries, Earth's power has been something to study and occasionally fear, but rarely to confront directly. The shutdown signifies not defeat but humility, a rare admission that technology and intellect still bow before geological will. The notion that the ground beneath could transform overnight reshapes the human sense of permanence. Even the mightiest institutions appear transient compared to the endurance of molten rock cycling through the crust. Meanwhile, across universities and observatories, new collaborations arise. Mathematicians model stress distributions, climatologists study how gas emissions might alter atmospheric chemistry, and biologists investigate how sudden thermal surges affect microbial ecosystems. The latter discovery is particularly fascinating. Yellowstone's extreme environments host life forms that thrive in boiling pools and acidic vents, organisms whose adaptations reveal the limits of biology. When the park shut down, researchers lost direct access to those unique habitats. However, remote monitoring indicates that microbial populations are shifting rapidly in response to rising temperatures. Some species vanish from known pools, replaced by new colonies adapted to hotter, more volatile conditions. This spontaneous evolution offers glimpses into life's resilience and raises profound questions about how ecosystems adapt to planetary stress. For local communities, however, scientific wonder offers little comfort. The closure has frozen livelihoods dependent on the park's 4 million annual visitors. Hotels stand empty, shops shuttered, and the once bustling towns of Gardner and West Yellowstone grow eerily quiet. Yet despite the economic strain, most residents support the shutdown. They have seen the strange omens, the subtle smell of sulfur on calm mornings, the sudden die-off of fish in streams that turned unnaturally warm, the tremors rattling window panes in the night. Instinct tells them something extraordinary is occurring, something that dwarfs human schedules and financial plans. In the hush of uncertainty, many gather at local halls to hear updates from geologists and park officials. Their faces lit by projection screens showing cross-sections of the earth beneath their feet. One of the most haunting aspects of this underground discovery is its invisibility. Humans are visual creatures. We fear what we can see: storms, floods, fires. But this danger is silent, hidden, patient. It manifests as tremors felt more in the chest than the ground, as faint warmth rising through soil, as mineral-rich steam whispering from unseen vents. There's a psychological weight to confronting a threat that lives beneath you, unseen but ever present. The park's closure symbolizes a confrontation with that invisible menace, a recognition that danger can lurk not in the sky but below, where molten memory sleeps. The scientific mission now transcends Yellowstone. Similar geological systems, Taupo in New Zealand, Toba in Indonesia, and Campi Flegrei in Italy, are being re-examined in light of this discovery. Researchers compare seismic fingerprints, looking for patterns suggesting the same kind of deep fluid restructuring that now grips Yellowstone. If parallels emerge, the world may face a new paradigm. Supervolcanoes not as dormant relics, but as dynamic, living networks responding to planetary changes. The Yellowstone event then becomes both warning and revelation, a real-time demonstration of processes that could one day rewrite global geography. In Washington, emergency planning agencies study worst-case projections. While they refrain from public speculation, internal documents explore how infrastructure, agriculture, and transport systems might withstand long-term geological disruptions. Airspace restrictions over Yellowstone remain in place, not just for safety, but to keep surveillance clear for monitoring satellites. Military and scientific interests converge, coordinating logistics for rapid evacuation or resource deployment should deeper instability emerge. The discovery has effectively merged science and national security, as the consequences of misunderstanding the system could ripple across states and economies. In academic circles, debates intensify. Some argue that the cavity's discovery could mark a self-stabilizing phase, a natural release of pressure rather than a buildup. Others warn that such optimism ignores the mathematics of stress accumulation. The Earth does not negotiate, it acts. The data suggests thresholds approaching critical points where small triggers yield exponential outcomes. Those arguing for caution win the day, leading to sustained closures and expanded monitoring budgets. The park's silence, though costly, becomes a buffer against catastrophe. The most compelling question remains what exactly caused the anomaly to manifest now. Some link it to regional tectonics, the slow drift of the North American plate over the Yellowstone hotspot. Others suspect climatic influences, melting glaciers and fluctuating groundwater levels altering weight distribution above the caldera. A few propose the influence of magnetic pole shifts subtly affecting magma movement through electromagnetic induction. While these theories differ, they converge on one truth: the planet is never still. Every layer, from core to crust, participates in an ongoing symphony of energy transfer. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Yellowstone's sudden shutdown? What do you think they discovered underground? We want to hear from you. Thank you for watching and see you next time.